Hello and welcome to Learn Data. It's great to have you on this video. I'm Nilesh and today we are going to talk about a real world application of data science, which is construction. Specifically, we are going to talk about counting grains of sand. And any guesses on how many number of grains of sand could be there in this pile of sand that you see on this picture? Well, by the end of this video, you'll definitely find out. Sand can be sourced from different sources, as you probably already know: rivers, lakes, and seabeds, and probably many others. And some of the applications for sand would be constructing houses, constructing bridges, can be used in sandpapers, and also making big islands in the sea. So, how does this all work? Well, it starts with grading the sand, and as you can see in this picture, there are several sieves that are shown and one on top of each other. So each of those sieves contains a mesh or sieve that has a specific opening, and if the particles of sand are smaller than that opening in the sieve, then they'll pass through the sieve, otherwise they'll get stuck there. So if we put certain amount of sand in the topmost sieve, which says 40 mm, and sifting through these, then we get graded particle size of each grain of sand in those sieves. Then if we weigh them and weigh how much amount of sand is there in each of those sieves and do some mathematics, and we can calculate fineness modulus. However, in this video we are going to use imaging to calculate the fineness modulus and see if we can arrive at a similar number. And for this, we are going to measure the area of each of these particles and then use these filters that are shown here to see how many of those particles exist in the sample that we take. So based on the fineness of modulus, it is then possible to qualify the type of sand. So is it a finer sand, is it a medium or coarse sand? So we'll be able to find what type of sand we are working with today. And to get a sample, so the heap of sand that you saw in the beginning of the slides, we are going to take a sample of 1 cubic centimeter. So here on the slide you see a paper basket that is 1 centimeter by 1 centimeter approximately, and we are going to use that to take a sample. So let's head out. Here it's a bright sunny day and I'm going to take a small scoop of the sand. So let's try. So this looks good, but we need it full, so I'm gonna take this. That should be plenty. So let's head in now. Okay, so this is the sand that we have, and we are going to now use it to create sampled images. Now when creating sampled images, sampling for images, it's important that we sprinkle very little of these grains of sand so that they don't touch each other. Here I'm going to sprinkle a little bit of sand, and as you can see, I'm trying to be very careful that they are very sparse, and this looks good. We also have the ruler on top. So that's how our image would look like when it was captured by a cell phone camera. If you have better cameras, then this would definitely be much clearer in resolution. We have a scale up top, then the background is purposely blue because it's easy to remove it as a background in imaging. And then those are the grains of sand, as we can see. If we zoom into each of those grains of sand, we can also look at the shapes. In this video we are not going to talk about shapes, but just wanted to show you that it's possible that we can also use imaging to quantify the shapes of these specific grains of sand that we have on this slide. Now once we have all those images, the next step is to remove the background. So if you see on the left hand side, this is the image of original image which has the background there. In the center image, the background is removed and it's now black in color and only the grains of sand are visible. On the rightmost side, these are the segmented that's the segmented image, and we can see that each of the grain of sand is now labeled with a different color, and also we have the number of pixels in each of those. So based on that, we can go ahead and calculate how much is the area for each of those grains of sand, and that's pretty amazing. Before we get on to looking at animations, I just want to show you what we are about to see. The animations are going to consist of three areas. On the leftmost side is the image that is being scanned. On the right hand side, there are two histograms. The histogram in the middle has an x-axis that goes from 0 to 2.5 square millimeters. However, on the one on the rightmost side has a smaller x-axis that goes from 0 to only 0.25, and the reason is because, as you'll see, as the number of images scanned progresses, most of the sand grain particles are in the area between 0 to 0.25, and that's represented by this tallest bar in the middle graph on the left hand side. In the scanned image that is being scanned, that's on the leftmost side here, in this image there are 3 grains of sand that are shown here, 1, 2 and 3, and this is denoted by the number here, n is equal to 3. Similarly, up top on these two histograms, there are counts of the total number of grains that have been scanned so far, and here, for example, 321 were counted so far, and both the counts are the same. So the counts on the right hand histogram also have counts of grain particles that are greater than 0.25. Now let's go ahead and watch the animation for histograms. Hope you enjoy it. Welcome back after about 400 scans. We now know that 1 cubic centimeter of sand that we sampled earlier has about 12,000 grains of sand. Now we can use that number to calculate how many grains of sand could be there in this pile of sand in front of you on the screen. Here I've gone ahead and assumed a trapezoidal shape, and based on that, the volume of that pile of sand is around 60 cubic feet. And when we crunch the numbers, what we get is about 2000 crores or 20 billion grains of sand that are in that particular pile of sand in front of you on that slide. That's pretty amazing. So now we are able to calculate this or estimate this, guesstimate this based on just imaging, and imaging a very small sample of the entire population of grains of sand that was available to us. I hope you enjoyed this video, and before I end this video, I also want to mention that the fineness modulus for these grains of sand was around 1.93. It's a bit lower than 2, but this could be considered as a fine grade sand, and this was based on area of the grains of sand that were seen in the images and not the actual weight of the grains of sand that is traditionally measured using the sieve method. So it's pretty interesting to see that although the methods are completely different, the numbers could be close, and it could be an alternative after much optimizing to use to calculate maybe fineness modulus or type of sand. That's it for this video. I hope you all enjoyed it, and if you have any comments or suggestions, please let me know in the comments below. I'd also be interested to know what was the number that you guessed in the beginning of this video, as to how many grains of sand could be there. That I'd really like to know that as well. Thank you, and please like, share and subscribe. I'll see you all in the next video.